In this video, we present results and some extensions of our new techniques for combining images in correspondence. First, we give a quick real-time demo of our user interface. The two input images are shown at the top. The halfway image and the real-time morph using current settings are shown at the bottom. The four graphs on the left panel show the functions of four transition parameters varying with alpha. They control the interpolation of low and high frequency, geometry, and color from two input images. As default, they are all linear functions from 0 to 1, reproducing the traditional morph. Next, we show our method for setting the transition parameters and create different image combinations. First, the user selects the whole image region and clicks a point on the graph to set the parameters on this point. A gallery viewer is then triggered. The gallery viewer allows visual navigation within the associated 4D combination space. The image that represents the currently selected 4D point is shown in the center of the gallery. The 8 images in the periphery show the potential results of advancing a fixed step in one of the 8 axis directions. The user modifies the central image by holding down the mouse button towards any of these directions. Here, the user selects a 4D point. We can see the 4 splines smoothly interpolate the user-specified point, and this is the morph after control. Our control can be spatially varying. The user selects the base region of the lamp with an intelligent scissor tool. And then, he modifies the intermediate frame with the gallery interface again. Please note here, these changes are only applied to the selected base region. The user designs a new base using a combination that is different from either input image. Here is the updated morphing animation after settings to the base. Our user interface also allows the user to do some non-affine interpolation by toggling the reflection mode, as shown here. With this, we can combine high frequencies from both input images. This is the final animation with reflection settings. Next, we show image combination results by traversing in the 4D interpolation space. The 4 parameters on the left are respectively associated with the low and high frequency color and geometry components of the 2 input images shown on the right top. They effectively define a 4-dimensional parameter space. Each image combination corresponds to a point in this 4D space. The 4 control curves here follow a 4D space-filling procedure curve. Traversing along this curve yields different but continuous image combinations. Our method can let user to extrapolate the parameters, achieving some compelling effects. Here we show extrapolation away from the coarse geometry of Schwarzenegger. We also allow some non-affine interpolation of high-frequency color and geometry, and then the 4D space becomes 6D. In this comparison, our result has no geometry high frequency, but both color high frequencies in the middle. This cannot be achieved by a fine interpolation as shown in the form of 4D traversal. Besides, we show some novel animated morphing sequences enabled by our technique. In this example, Our morph starts earlier on the right than on the left, creating an effect of smoothly combining lizard and human spatially. In this morph, the beef gradually warps into the shape of the apple, and the stem and leaf suddenly appear to get a beef-made apple. Finally, it gets the low-frequency color of the apple, but still keeps the beef's texture. In this example, the actress progressively replaces the high-frequency color and geometry from the painting, making the Mona Lisa look like the actress. Similarly, in this example, the real rabbit becomes an origami in the real environment by morphing the high-frequency components of both color and geometry. Our techniques can extend to videos as well. In this example, by combining the high frequency on the face, we'll make a third-person talk.
My favorite color is honey chestnut.
This is another video example, but here the input one is a static picture. Thanks for watching.